This is a completing part of today's lecture. For some reason, it didn't appear when I gave the lecture today. So this is a complement to the lecture 4 about segmentation. And so let's get started. Segmentation, what does it really get us? So if we have started our analysis, you knew from before that we had maybe 32-bit images or maybe 16-bit images, and that gave us quite a lot of data. And sometimes it's actually sufficient to only have discrete values. So it could be true or false or something, just telling, or just a few faces, could be bone, air, or something like that. And that gives us a dramatic reduction in data. So from having 56 gigabytes per sample, we all of a sudden only have 1.5 gigabytes. And that makes a difference if you can have it and work it with it to some degree at least in your own laptop. The 56 really needs a big workstation to work with. So what is segmentation? In principle, it's an operation that brings us from the gray level image into a bi-level image. And for that purpose, I have created this cross image with some noise. It's quite noisy, but still it's okay. And that is what we're going to use now in the following slides to investigate what actually the segmentation can do for us. First step is mostly to take a look at the histogram. And we have seen it before. It tells us about the gray level intensity distribution. And we can see in this particular case that we have a large collection of pixels at low intensity and some few at higher intensities. This already gives us an idea that we can actually separate the two quite well. So let's try it and see what happens. We apply a threshold. In this case, I choose to set the threshold at 0.4, and then we apply that to the image and see what happens. And here you can see that with the threshold at 0.4, we definitely get the whole cross, but we also get some pixels outside. So these are misclassified false positives. We don't get any false negatives. So that's good. So 0.4 can be seen as a decent threshold for this case. We can also try to see what happens if we apply different thresholds. So here I have a set of different thresholds to test. And if we do that, we can see that if we have a too low threshold, we have a lot of misclassifications. And with increasing values on the threshold, you can see that there are less and less misclassifications. Actually, this one doesn't have any misclassifications at all. And if we go back a couple of slides, we can see here that that was at about here. And we have a nice separation between the two classes in this case. And let's go back. And if we increase the threshold even further, then we start seeing that we actually lose pixels from the cross. And at the very high threshold, you have lost even more pixels. So if we want to look at the case where we segment a practical example, and in this case, we want to look at segmenting cells. And now we want to look at the real thing. And see here, we have an image of some cells in a culture. You can see all the black dots are our cells. And from this, we get the histogram. But in this case, the histogram doesn't have two distinct modes. It just has a long tail going down to the darker values. So here is now the question how to set the threshold without losing or doing misclassifications. And that's not a given, but let's try doing something. If we apply the threshold at 100, we can see that there are some cells, but in the upper left corner, it's not so dense as we may want to think. If we look at this image, there should be some more, and they should also be larger than we actually see here. If we increase further, we see that they are increasing, but at the same time also they are increasing in size in this corner. And that is an effect that we can observe in the following images here. And in this case, it's extreme. You can see really there are big blobs and most likely also misclassified false positives, quite many. And the reason for that is that we have a gradient in the intensity across the image. So it's, I would say, a diagonal gradient, and that is what gives us the problem. After the break, we will look at a method to correct for this, but for now we just state the fact that we have a problem. We can also look at other types of images. In this case, we look at vector images. So we not only have the intensity, but we also have a vector describing the direction of the measurement. And looking at that, we can look at the pair plot. So that is a plot where you do pairwise histograms of different informations. So looking at the first two, they are quite obvious. It's just x versus y, so it's the coordinates, they cover the whole image. And then we have the detector intensity versus the dimensions, versus the positions. And then we have also the x vector and y vector versus the intensity. Doesn't tell very much, but you can see down here that the x and y vector actually describe a circle. So this is what this plot tells. In some cases, when you have complicated data, it can give you a pretty good idea which variables actually are connected and what they can give you. So plotting it as a vector field, you can see here you have some centrally radial rays going out. So it looks like all these directions, they point outwards. And we even put the color map on the detector value. So you can see there are some great values in the middle and some darker values in some directions. Now, how can we segment this? There are different ways. One is looking at the values, and other ways also looking at the directions, and the positions. So in this case, if the x component is greater than a quarter and the y component is greater than a quarter, then we set 1. And that gives us this visualization. So we can have, in that way, we can have a position segmentation, and that can be good if you want to identify some specific regions or analyze a specific region. And if we look at the histogram of these vectors, then it should look like this. Then we see here, we have the bivariate histogram. You can see some positions have more values than others. And then we are looking in this corner where we have x greater than a quarter and y greater than a quarter. So that is still our corner here. And we can see what information we have. We can also apply a threshold on different values. So in this case, we look at the direction and see what happens. Or actually the amplitude, sorry. We can look at the orientations, saying that if the angle of the vectors is within some interval, then we should set 1. And that brings us to the end of this unfortunately missed part of the lecture today. Thank you.